Alright guys, welcome back. I know we didn't have a video for the last section, but it wasn't too bad. So we are going to start our quarter 3 review study guide. I'm going to try and do it every 2-page for a video, so it's not going to be too overwhelming. And hopefully the scratchy noise from the last ones is gone because I can't really tell. Alright, so let's go ahead and dive in to this first question. So here we have factor 27x to the third minus 512. Whenever you have an x to the third power and you don't have another x anywhere, you check to see if it's going to be a sum or difference of perfect cubes, because that would be the SOAP formula. So let's go ahead and try that out. If we wanted the a, we're going to take the cube root of our first term, which is 27x to the third power, and we see that the cube root of 27 is perfect, it's 3, and the cube root of x cubed is just x. Now we have to check if b is also a perfect cube. You do not take that negative, right? You only take that term, which is 512, and it in fact is 8. So 8 times itself 3 times is 512. Now that it is a difference of perfect cubes, we're going to do that SOAP formula, where it's a squared, ab, b squared. And to figure out the signs, it's same, opposite, always, positive. And those are the signs. So same is what you started with, and that was negative, so we're keeping that the same. Then that's the opposite, so it's plus, and it's always going to end in plus. And let's adjust. All right, we'll see if that holds up. So now that we have the formula we're going to plug into, we can easily just plug in our A's and B's. So A is 3x, and we're subtracting it from our B, which is 8. And it's A squared, so it's parentheses 3x, all of that squared, plus A times B. 3x times 8 is 3 times 8, which is 24x, plus b squared, which is, let's take one more final step, right? The first parenthesis doesn't change, it's still 3x minus 8, but this one, you're squaring all of a, right? You're squaring the 3 and you're squaring the x, so you have to distribute this too. So 3 squared is going to be 9, and when we square the x, it's just 9x. Now the SOL always tries to trick you because this is going to be an option, 3x squared, because they know you forget to square the 3. So just remember, it squares every part, the 3 and the x. Then we still have the 24x, and we have the 64. And we're done. That is our totally factored form, and that would be our final answer. Next question, right? We are multiplying exponents and numbers. First step, let's see if we can get rid of anything. I notice there's a t to the 0 power. Anything to the 0 power is 1. And if you multiply by 1, it doesn't change anything. So I'm just going to go ahead and cross it out. Next up, we do Pemdas. So we have parentheses. We have s to the third raised to the 5th power. So that's s to the third, s to the third, s to the third, s to the third, and s to the third. That's 15 s's. Or if you remember the property, you distribute and you multiply. So the negative 30 stays. Right? But now it's going to be s to the 15th power. And we have that s to the negative 3rd power. And on the bottom, we have s to the 10th and 5t. Okay. I'm just going to go ahead and see if I can combine anything. So I have a negative 30 here. And I see that there's an s to the 15th times an s to the negative 3rd. When we multiply exponents, we add those numbers on top, the exponents. So we're going to actually end up with s. So 15 plus negative 3 is 12. So we get s to the 12th. On the bottom, we have 5t s to the 10th. The goal when we simplify is that we simplified all the numbers if we can, and we only have one of each letter. I notice there's still two s's, and I notice negative 30 and 5 can be simplified as well. So negative 30 divided by 5, that's just exactly negative 6, and it goes on top. Right? Then we have s to the 12th divided by s to the 10th. When you divide, you're going to subtract the exponents. 12 is bigger, so the final answer is going to go on top. So now we do 12 minus 10, which is 2. So on top we're left with s to the 2nd power. And on the bottom, the 5 went into the 30, so that's gone. This s to the 10th disappeared, which means the only thing left is the t. Now we only have an s show up once and a t and a number. So that's our final answer. Okay. Next up, we have composite functions, which is what our last unit was on, so hopefully that should be fresh in our minds. They've given us f of x and g of x, and we're doing the following operations. We're taking f of x and we're adding it to g of x. So f of x is 2x plus 7, and we're going to add it to our g of x, which is 2x squared minus 9x minus 56. And we always say put parentheses, so I'm going to go ahead and do that. Since it's addition, it doesn't really matter to distribute, so I'm just going to go ahead and combine like terms. There's only one x squared, so that stays the same. And if it helps if you cross out what you've already done and moved, that way you don't lose track. Alright, then we have a 2x and a negative 9x. We can combine those. So 2x minus 9x is negative 7x. And I've just combined those, so those can cancel out. And then we have 7 minus 56. I don't know what that is off the top of my head, which is a little embarrassing, but that's okay. Let's go ahead and whip out our calculator. Let's see, 7 minus 56 is negative 49. That's negative 49. No need to factor, so I'm just going to leave that. There it is. F of x plus g of x will give us this. Go ahead and bring down that barrier. Next up, we're taking f of x and now we're subtracting it from g of x. So I'm going to go ahead and rewrite the same thing. 2x plus 7, and then g is 2x squared minus 9x minus 56. And we're subtracting them in the middle. Since it's subtraction, you have to distribute the negative to that second set of parentheses. So we're distributing it to g of x because we're subtracting every single part. So if I rewrite it, it becomes 2x plus 7 minus 2x squared plus 9x and plus 56. Now that we've gotten rid of the parentheses, we can go ahead and combine like terms. There's a negative 2x squared. That doesn't combine with anything. We have a 2x plus a 9x. That becomes 11x. And then we have a 7 plus a 56. Right? So 7 plus 56, let's see, that's 63. And again, we don't have to try and factor. I can go ahead and stop right there. Okay. Next up, we have multiplication. That definitely needs parentheses. So that's going to be 2x plus 7 times 2x squared minus 9x minus 56. So now that we are multiplying two parentheses, that means we have to FOIL. FOIL, FOIL, FOIL. That's basically a distribution property. So I'm going to distribute it to everything. So this becomes 4x to the third power. This becomes negative 18x squared. And let's see, 56 times 2 is 112. And then we distribute the 7 to everything. So that becomes 14x squared minus, let's see, 63x, and 7 times 56 is 392. Okay, now that we've finally distributed everything, I can go ahead and combine all my like terms. There's only one 4x cubed, can't combine it with anything. But we have a negative 18x squared and a 14x squared. Right, so if we combine those, we get a negative 4x squared. So those are now gone. Then we have a negative 112x and a negative 63x. That's 175x, well, negative. And then we just have one constant number. Seems like a big number, big bunch, big answer, but that's okay, because that's what the answer is. So we're good. 3 more to go for the composite functions. So here we are dividing, because everyone loves dividing. F of x is 2x plus 7. G of x is 2x squared minus 9x minus 56. So whenever you have a fraction, we are going to factor just to see if anything cancels out. So we have 2x plus 7, and then you can factor using any method that you've learned and are comfortable with. Let me bring this up. You can do the tree method, you can do the box method, the guess and check method, anything that you want to do. Let's see, I think 7 goes into this. Yep, 7 and 8. So let's see, 2x, this is 16 minus 7 is 9, so that's good. And we want it to be negative, so that is going to be negative, positive. Now that we have a fraction and it's factored, we have to restrict the domain. And that's when you take the denominator and set it equal to 0. So if we take x minus 8 set equal to 0, we get 8. And if we take 2x plus 7 set equal to 0, we get negative 7 halves. And we notice the 2x plus 7 cancels. When nothing is left on top, that's technically 1. And on the bottom we have x minus 8. E, but that's fine. That's our final answer. Okay, sorry, I'm letting the video catch up to my voice. Alright, so hopefully it has caught up. Let's do part E. I'm going to do part E a little bit on the corner since I went over. So this is saying f of g of negative 5. And we always work inside out. So first, I see negative 5, and I'm going to find g of negative 5. So I know g of x is here, and instead of x, I want negative 5. So wherever there's an x, we're evaluating, we're plugging in that negative 5. So g of negative 5, that becomes 2 times negative 5 squared, minus 9 times negative 5, minus 56. So this becomes 5 times 5, which is 25. 25 times 2 is 50, plus 9 times 5, which is 45. And we're subtracting it from 56. So it's 50 plus 45 minus 56, which is 39. But that's only g of 5, negative 5. We still want f of that. So instead of g of negative 5, we now know that g of negative 5 is 39. So now we want f of 39. So here's f. Instead of x, we're going to put 39 in. So that is f of 39, which is 2 times 39 plus 7. So 2 times 39 plus 7, bless you, is 85. You're good. And so there we are. 85 is our final answer because we worked inside out. We're going to do the same exact steps for part F. So part F, again, we're inside out. We have 7, and we're going to put 7 into our F. So F of 7 is 2 times 7, which is 14, and 14 plus 7 is 21. So now we know F of 7 is actually 21, and we work again outside. Now we want G of 21. So G of 21 is going to be 2 times 21 squared minus 9 times 21 minus 56. So 21 squared, let's put that in the calculator, we get 441. Multiply that by 2, we get 882 minus 9 times 21, which is 189, and subtract that from 56. So let's put that in our calculator. It's 189 minus 56. And we get 637. There's our final answer. So those were our composite functions. If you need to review, definitely go back and look at our quiz 17 stuff. Just going to move the next one up for our calculator. Alright, what's wrong? So, the next question. I don't have a graphing calculator with me, but we can write down the steps and you'll be able to find it on your own. I don't recommend using Desmos for this problem because it's just a lot more memorizing than a typical calculator. So, let's read that question. It says, find the polynomial of best fit, there's a hint to what we need to do, for the following data. And they give you 1, 2, 3, 4 points. Whenever it asks for the polynomial of best fit, that is always going to be a regression problem. So regression. That is definitely all calculator. Okay. So always for this problem, you want to make sure your diagnostic is on. So to do that, step 1 is going to be hit the second and then number 0. Go all the way down until you see diagnostic on and hit enter until it says done. Now that you have that, you know you're safe to go and you start the official steps. So now this is where you hit stat and enter. Once you have that, you're going to go ahead and L1, put all the X's, and in L2, you're going to put all of the Y's. Once you have those in, your next step is to hit stat again. Hit the right arrow until you're under the highlighted word calc. Okay. Now you have to choose between number 4, 5, 6, or 7. Okay. Those are the linear reg, quad reg, cubic reg, quartic reg. Okay. And if you need to, you try every single one and you compare the R squares. Whichever R square is the best, which is 1, that's your answer. Or if you wanted to, you do the trick. There's 1, 2, 3, 4. There's 4 data points. Take away 1, it's cubic. All right, so that would be option 5 or 6, I believe. It says cubic reg. All right. And basically what you should end up with when you round, it's going to be negative 0.003 x to the third power plus 0.18x squared minus 0.91x plus 8.2. And they wanted the equation. There it is. They didn't need anything else. So we're going to be done on that one. All right, these are regression problems. If you need more practice, go look up stuff on Khan Academy if you need to. All right, that's page 1. I don't want it to get too long, so I'm going to stop the video here and go watch the next video for page 2 and so on. All right, have a great day.